Hello everyone, this is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about chi-square distribution, third method. Okay, so test of hypothesis for small samples. So what is small sample? If n is less than 30, then we can say that is small sample. Actually, there are three types of small samples are there. So T distribution, F distribution, chi-square distribution. So in T distribution, we have two methods. Okay, but in the chi-square distribution, the last method is to find the chi-square distribution. Here we have to test whether there is any significance difference between observed and expected frequencies. We use chi-square test. So chi-square test formula is summation OI minus EI whole square by EI. So here OI is the observed frequency and EI is the expected frequency. So in a chi-square distribution, we have taken chi-square alpha value. So chi-square alpha value from the table at nu equal to r minus 1 into c minus 1 degrees of freedom. So that means chi-square alpha we have to choose from the table at nu equal to rho minus 1 into column minus 1 degrees of freedom. Rho minus 1 into column minus 1 degrees of freedom. So method 3. So in the method 3, we have to find the expected frequency by using rho total into column total divided by grand total. Rho total into column total divided by grand total. So that is our method 3. So here we have a first problem, that is the following table gives the classification of 100 workers according to gender and nature of work. Test whether the nature of work is independent of the gender of the work. Okay, so here we have so one table is there, that is based on stable, unstable, male, female. Okay, so here stable is for male stable 40, for male unstable 20, for male stable 10, and for female stable 10, for female unstable 30. So these four are observed frequencies. The given frequencies, we know that the given frequencies are always observed frequencies. That means here the OI values are 40, 20, 10, 30. Or you can take like this also, 40, 10, 20, 30. Okay. So next, the total is 40 plus 20 is 60. The row total, this is row total, right? These are all rows and these are all columns. So row total is this one. So 40 into 20 is 60. 10 into 30 is 40. And column total is 40 plus 10 is 50 plus next row total is 20 plus 30 is 50. So the grand total is 60 plus 40 is 100, 50 plus 50 is 100. So this is called as a grand total. So this is these two are row total. So these two comes under column total. Now coming to the problem, given that the expected frequencies, we need to find the expected frequencies by using row total into column total divided by grand total. So this is the formula for expected frequencies in third method. So row total is here. So here the row total is 60 and the column total is 50. So 60 into 50 divided by grand total is 100. So 60 into 50 divided by 100, that is 30. So like that, row total is 60 and the column total is 50. 60 into 50 divided by 100. So 60 into 50 divided by 100, that is 30. Okay. So next one is row total is for this value. I am doing for this value. So this value row total is 40 and the column total is 50. Okay, so row total is for, I am finding for this value. So that's why I am writing here. So that value is 40 into 50 divided by grand total is 100. So 40 into 50 divided by grand total is 100, that is 20. So next one is also next value I am doing for this value. Okay, so here the row total for this value is 40 and column total is here 50. So what grand total is here 100. So that's why that is a 40 into 50 divided by 100. So 40 into 50 divided by 100, that is 20. Okay, so these are all expected frequencies. These are all expected frequencies. So if we take 40, 20, 10, 30 like this, 40, 20, 10, 30 like that, then you can take the expected frequencies also in the same way. Okay, so that means 30, 30, 20, 20. So you need to take 30, 30 first rows, after that columns. Okay, so if you take column wise, that means 40, 10, 20, 30, 40, 10, 20, 30. Here also you need to take like that only. Okay, so that is 30, 20, 30, 20. So these are the expected frequencies. Same way you need to follow. If you take row wise, then in the observed frequency you need to take row wise in expected frequencies. If you take column wise in observed frequency, here also in expected frequency also you need to take column wise. Okay, so but here I am taking row wise. Okay, so that is 40, 20, 10, 30. Observed frequencies are so 40, 20, 10, 30. Row wise I am taking 40, 20, 10, 30. So 40, 20, 10, 30. And the expected frequencies are already we have solved here. Here also we need to take a row wise. Okay, so that is 30, 30, 20, 20. So row wise I am taking here 30, 30, 20, 20. Okay, so now we need to calculate y minus ei whole square. That is 40 minus 30 whole square. That is 10, 100. So I do 20 minus 30 whole square 100. 10 minus 20 whole square, that is 100. 30 minus 20 whole square, that is 100. So like that we need to find y minus ei whole square by ei. So y minus ei whole square is this one, divided by ei is, so that is 100 divided by 30. 100 divided by 30, that is 3.3. So 100 divided by 30, that is 3.3. So 100 divided by 20, that is 5. 100 divided by 20, that is 5. So if you add all these values, so that means 3.3, 3.3, 5 plus 5. So if you add all those values, we will get 16.6. That means chi-square equal to, we know that sum of all these values, y minus ei whole square by ei is always nothing but chi-square. So chi-square equal to summation y minus ei whole square by ei, that is equal to 16.6. Next, null hypothesis. So null hypothesis is denoted with H naught. So H naught is here I am considering y equal to ei. So that means there is no significant difference between observed frequency and expected frequency. So next one is alternative hypothesis, that is denoted with H1. So alternative hypothesis is nothing but opposite to the null hypothesis. So that means here we are taking y not equal to ei. So that means there is the meaning of y not equal to ei means there is a difference between observed frequency and expected frequency. Now we need to calculate level of significance. So in the question they have not mentioned alpha value. So that's why we need to assume that alpha is assuming, here I am assuming alpha value, assuming alpha equal to 0.05. So now we need to calculate chi-square alpha at nu equal to rho minus 1 into column minus 1 degrees of freedom. So rho minus 1 into column minus 1 degrees of freedom. So here we have how many rows are there? Only 2 rows are there in the question. Only 2 rows are there. How many columns are there? 2 columns are there. So 2 rows and 2 columns. Rows are 2 and columns are also 2. So that's why this is chi-square 0.05 at nu equal to 2 minus 1 into 2 minus 1 degrees of freedom. So that is chi-square 0.05 at nu equal to 2 minus 1 is 1 and 2 minus 1 is 1. 1 into 1 is 1. So nu equal to 1 degrees of freedom. So chi-square 0.05 at nu equal to 1 degrees of freedom is. So chi-square 0.05 at nu equal to 1 degrees of freedom is 3.841. So we have to take this value from the chi-square distribution table. Okay. So we have to take this value from the chi-square distribution table. So next one is test statistic. So test statistic chi-square equal to summation y minus ei whole square by ei. So already we have calculated this value here. Okay, 16.6. So that is 16.6, but we need to calculate mod chi-square, that is 16.6. So next, coming to the conclusion, chi-square is 16.6 and chi-square alpha is 3.841. So 16.6 is greater than 3.841. That means chi-square, mod chi-square is greater than chi-square alpha. That's why we reject null hypothesis. That means we reject our statement. So the calculated value is greater than tabulated value. So that's why we reject null hypothesis. That means our statement is wrong. That our given statement is wrong. So what we have taken in the null hypothesis, that is y equal to ei. That means there is no significance difference between the observed frequency and the expected frequency is a wrong statement. So what is our correct statement here? There is a significance difference between observed frequency and the expected frequency. That is the answer. Next problem is on the basis of information given below about the treatment of 200 patients suffering from a disease, state whether the new treatment is compared superior to the conventional treatment. So here we have a table that is nu. Nu is 50 for favorites and nu is 30 for not favorable. So favorable, nu is 60 for favorable and nu is not 30 for not favorable, and conventional is 40 for favorable and conventional is 70 for not favorable. Okay, so if you add 60 plus 40, column total is 100 and in the second column total is 100. Okay, 30 plus 70 is 100. So like that, row total is 60 plus 30 is 90. Row total, first row total is 90. Like that, second row total is 100. So these four are observed frequencies, y values, observed frequencies. 60, 40, 30, 70 or 60, 30, 40, 70. So these are our observed frequencies. So how to find the expected frequencies? We have a formula that is row total into column total divided by grand total. So what is the expected frequency formula? Row total into column total divided by grand total. So these two are row total. So these two are column total. What about the grand total? The grand total is this one, 200. Grand total. So coming to this value. So coming to 60. In place of 60, we need to write row total. So 60 row total is 90 and column total is 100 divided by 200. So 90 row total into column total is 100 divided by grand total is 200. So if you simplify this one, we will get 45. So like that, in place of 30 I am doing. So for 30, row total is 90 and column total is 100 divided by grand total is 200. 90, row total is 90 and column total is 100 divided by the grand total is 200. If you simplify this one, we will get 45. Okay. So in the next case, I am doing for this one, 40. So for 40, the row total is 110 and the column total is 100 divided by the grand total is 200. So 110, row total is 110 and the column total is 100 divided by the grand total is 200. Simplify this one, we will get 55, that is. So like that, for last value, that is 70. For 70, the row total is 110 and the column total is 100 divided by grand total is 200. So row total is 110 and column total is 100 divided by grand total is 200. So simplify this one, we will get 55. Okay, so here the observed frequencies are, if you take row wise, that is 60, 30, 40, 70. So 60, 30, 40, 70. Here I am taking in the row wise. Okay, so row wise I am taking. So that's why here also you need to take in expected frequency. This is expected frequency table. Expected frequency. This is expected frequency table. So in expected frequency also we need to take row wise. So that means 45, this is 45, this is 55 and this is 55. Okay. So like that we need to take. So expected frequencies are 60, 30, 40, 70. Here I am taking the row wise, and the observed frequencies are given frequencies. For observed frequencies here I am taking row wise. That's why that is 60, 30, 40, 70. And coming to the expected frequency, here also we need to take row wise. So that's why that will be 45, 45, 55, 55. So now we need to calculate y minus ei whole square. Y minus ei whole square. So that means 60 minus 45 whole square, that is 225. 30 minus 45 whole square, that is also 225. 40 minus 55 whole square, 225. 70 minus 55 whole square, that is 225. So next coming to last one, that is y minus ei whole square by ei. That means y minus ei whole square divided by ei. That means that is 225 divided by 45. 225 divided by 45. So 225 divided by 55. 4.09. 225 divided by 55, that is 4.09. So add all these values. That means 5 plus 5 plus 4.09 plus 4.09. You will get 18.18. That means the sum of y minus ei whole square by ei value. This one is. So that is nothing but that is chi-square value. Okay, so but here we have calculated chi-square value, but we need to follow the procedure. So what is that procedure? So first one, we need to set up the null hypothesis, alternative hypothesis, level of significance, test statistic and conclusion. So in this test statistic we need to write the formula. So what is that formula? This is our formula. Okay, so already we have calculated the test statistic value, that is 18.18. So first step is we need to set up the null hypothesis. So null hypothesis is denoted with H naught. So that is nothing but y minus y equal to ei. That means there is no, here I am taking, there is no significance difference between observed frequency and the expected frequency. Like that in alternative hypothesis, that is denoted with H1. So y not equal to ei, because alternative hypothesis is nothing but opposite to the null hypothesis. So next, level of significance. So level of significance is alpha. That value is not mentioned in the question. So that's why I am assuming that alpha equal to 0.05. So now we need to calculate chi-square alpha at nu equal to r minus 1 comma c minus 1 degrees of freedom. So that means r is nothing but row and c is nothing but column. Okay, so how many rows are there in our problem? Here we have 2 rows are there. So 2 rows, and how many columns are there? 2 columns. Okay, so that means that is chi-square 0.05, because alpha value is 0.05 we are assuming, and nu equal to how many rows are there? 2 rows, 2 minus 1, and how many columns are there? 2. So that is also 2 minus 1 degrees of freedom. So now 0.05 at nu equal to 2 minus 1 is 1, and into 2 minus 1 is, that is also 1. So 1 into 1 is 1. 1 degrees of freedom. So 1 degrees of freedom is 3.84. Okay, so chi-square 0.05 at nu equal to 1 degrees of freedom is 3.84. So that is chi-square alpha value we have taken from the table. Okay, so next step is, our fourth step is test statistic. So our fourth step is test statistics. Here we need to write a chi-square formula, chi-square distribution formula. The chi-square distribution formula is chi-square equal to summation y minus ei whole square by ei. So already we have calculated in the table, that is 18.18. That value is 18.18. So therefore chi-square equal to 18.18. Okay, modulus of chi-square. But we need to calculate modulus of chi-square. No, we have to if we have negative value also, we have to convert into positive. So that's why modulus of chi-square equal to 18.18. So next one is conclusion. Okay, so here chi-square is, so chi-square value is 18.18 and chi-square alpha value is 3.84. So 3.84. Obviously, this is 18.18 is greater than 3.84. 18.18 is greater than 3.84. That means modulus of chi-square is greater than chi-square alpha. So if modulus of chi-square is greater than chi-square alpha, we reject, in the fifth step, we reject null hypothesis. That means our statement is wrong statement. What is our statement? We have assumed in the null hypothesis. So because null hypothesis and alternative hypothesis both are assumptions, that's why we have assumed in the null hypothesis. So what we have assumed? So we have assumed that there is no significant difference between observed frequency and expected frequency. So here our assumption is wrong. That means there is no significant difference between observed frequency and the expected frequency is a wrong statement. So that that means what is that solution here? Here the answer is there is a significant difference between the observed frequency and the expected frequency. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.